Yes. Okay. Hello, everyone, and welcome to Caribbean Developer Week. This evening, we are going to be talking about static code analysis. And today we have Obika Gellineau
Yeah, no,
as
no.
our presenter. Um, my name is Natalie O'Brien, and I will be moderating this event this evening. So here's a little bit about Obika. He is a security professional with over 8 years experience in information technology and forensic and works for KPMG Advisory Services, where he develops and implements cybersecurity solutions and services for various clients. And today he will be presenting and demonstrating on static code analysis. Um, so I'm going to hand it over to Ubika. The floor is all yours.
Thanks, Natalie. Afternoon, everyone. Uh, Static code analysis, right? When this came about, when the whole idea of Caribbean Developer Week kind of came up on Facebook, I said, well, I know a lot of people are going to probably come on and talk about coding on different platforms and probably speaking about business, freelancing. I saw one or two persons talking about, or one person talking about remote development. So seeing as I'm a security professional and I've been in the business for a while in terms of software, well, cybersecurity on the whole, which kind of includes software security, I said I'll do something with regards to a kind of developer-focused security solution, and talk about a way in which developers can, improve their coding quality and minimize risk when you actually develop code and put out an application out there. Because as you know, the world is the whole environment, the whole web space or the internet environment has now become like the Wild Wild West. Every so often you're hearing data breaches. Just the other day, someone was hacked. I think it was a company in the UK who owns Curry's PC. Curry's PC is like the Radio Shack in the UK. It's about over 1,000 or something records that those hackers stole from that company. And a lot of people in this group would be producing a lot of web applications for business owners. So you would want to ensure that those web applications are properly secured and that you have gone about all the activities or all the best practices to properly, code and implement your web solution for your client.
Yes,
or the company that you work with as well.
Yeah, and I think that is very key now because there are a lot of people getting the hack, and this is something a lot of developers overlook.
Yes.
And it's coming more and more important now.
Yeah. So the reason why I chose static code analysis is because this is one of the more preventative measures that a developer can implement. Right, and as I'm going through the presentation, you'll kind of see the areas in which developers can, more or less put into their routines or by extension use. Well, we're going to talk about a automated tool today, a free and open source automated tool called Sonarqube, yeah, you'll also get a demo. So let me just go straight into the presentation here. So today we'll just be going through just the usual basics. What is static code analysis? We'll talk about manual versus automated. That is manual review of your code versus the automated solutions. What are the differences? We'll also be talking about the benefits as well as problems with static code analysis. We'll be looking at it in terms of how it impacts the software development lifecycle. as well. And we will also look at the various automated static code analysis tools that there are out there. They're both open source as well as paid versions, right? We'll also kind of go through a demo that I kind of put together today. And last but not least, we'll also be just, doing a quick recap as to what we spoke about earlier in the presentation. So what is static code analysis? Basically, it's, examination of the actual source code without executing the program. So you are looking more or less at the code itself, the way how the code is structured, the way how the code is phrased, how you define your variables, how do you ensure that you put proper try-catch blocks in place, method overloading, so on and so forth. You look at all those aspects and you try to see where your gaps are or where your issues or security bugs are in the code, right? This whole practice is around web and non-web applications. So it doesn't necessarily have to fit in to a web application. It could fit into a desktop application. It could even fit into something that is backend. There are actually static code analysis tools for SQL, right? I didn't actually put that in the presentation, but I'll probably try and see if I can mention some of them another time, right? This is also known as white box testing. White box testing means that you already know what the application does and you understand what the application can do. So it's more or less, you don't have any issues with not knowing what the application does, as opposed to like with black box testing. Black box testing is where you don't know anything, so you try and find out, right? This is more or less known as white box testing. Continuing onward. So this type of practice could more or less be done either manually or through automated tools, right? We'll speak about that in a bit. And testers, most of the time when people are actually doing static code analysis, they need to at least know and understand the code structure and the source code's programming language idiosyncrasies. So when I say idiosyncrasies, as in, the things that make that actual programming language unique, right? A tester needs to at least have that sort of knowledge in order to do this. Also, it's the whole idea behind it is to detect flaws through the software's inputs and outputs that can't be seen through dynamic scanning, right? So whereas dynamic scanning more or less kind of looks at, most of the times dynamic scanning looks at the inputs alone. It doesn't really look too much at the outputs. This type of analysis actually goes through both inputs and outputs and looks at through the flow of the application. So I mentioned manual versus automated. So you have two types of static code analysis reviews. The first one being the manual review, and then you have the automated one. Manual review means that a secondary person or even another two persons, it depends on how many people you want to do reviews on the code, right? They would actually review the code. Once you have actually built your application, they would actually physically go through the code with you via a walkthrough, right? And then they will check to make sure that you've actually coded your application properly, there are no flaws, and try to ensure that your code comes out more or less clean, right? when I used to work in First Citizens, sometimes we used to do those manual code reviews depending on how difficult the actual change was, right? If it was a lot of changes made to a particular system, we actually had to do a peer review. I don't know if the practice is still being done here or if they've changed it around, but I know a couple of companies inside Trinidad and Tobago, they actually do code reviews before they actually move their application or their changes into production. Another thing about manual code review, it can involve multiple participants and it can go through multiple phases. When I say that, as in you can review now, they find a bunch of faults, you have to change those faults, and then they do another review again. And then they may find more faults, and then you have to change those faults. So and by extension as well, if you have more than one reviewer, you can have that one reviewer doing one review and then the next person doing a next review. And it can take a while. It's very time consuming with the manual code review. Whereas the automated code review, it's actually a lot faster. What happens is that you have an automated software tool that actually goes through the source code, takes a look at it and determines where the issues are in that source code and actually brings it up. And we'll see some of that later in the demonstration. Just give me 1 second here. I just need to hide something here. Right, good. So even though we have manual and automated, both really involve the use of pattern and lexical analysis to find bugs and software vulnerabilities and logic flaws in your code, right? Always remember that this type of analysis is a preventative measure, right? It's to prevent as much vulnerabilities and bugs going into your software before it goes into production. However, it doesn't really cover a lot when it comes to quality analysis of your code. And we'll kind of get into the problems a little bit later on. So in terms of benefits of static code analysis, so I have it here separated by manual and automated again. In terms of benefits, the biggest benefit is that, at least for manual, is that it improves coding quality. Reason being is because when you do a peer review, it's very likely that the peer review will be done by someone who is senior. So if you're a junior developer, you get that, I guess, coaching from the senior developer. It kind of improves your approach and by extension, the quality of your code over time. So you get that, sharing of knowledge or that passage of knowledge, right? The other advantage of manual code review is that the knowledge of the application functionality is shared. If you are working in a development department, sometimes it's good to ensure that you are not the only person who knows what's going on with this application. Because one day something may happen and you may not be able to continue. Somebody has to pick it up. By extension, it kind of ensures that, there's some level of redundancy and work doesn't stop on the application as well. So, and last but not least, I have here 2 eyes are better than 1. Reason being I said that is because sometimes it's good to have somebody, just double checking your work, making sure that you've done everything that you have to do. That's a positive as well with manual code reviews. And in terms of automated reviews now, any developer more or less can do an automated review, because what happens is that you kind of drop the peer or the person who is doing the review, and you now leave it up to a software tool in order to do the review. Or by extension, you can have somebody who is operating that software tool while you just focus on the development, right? the whole idea of this automated tool is more or less to kind of speed up things. And also to kind of limit complexity as well, because sometimes source code could be like hundreds of thousands of lines of code. And in order for somebody to actually go through all of that might be very tedious. So a software tool kind of cuts down on that, right? Scanning tends to be very effortless with the automated static code analysis tools. And it's more or less ideal for agile and DevOps developments, as well as continuous integration. That's one of the more or less the biggest advantages of automated static code analysis versus the manual. So we talked about benefits. We also have the problems as well. So in terms of problems, I guess the main problem with the manual one is that it's heavily reliant on senior developers and quality assurance staff to perform the review. If there's nobody around to do it, you may have delays in getting your code into production. Also, manual reviews can be very time consuming, and I just spoke about that. You could have multiple phases, as well as it may take a while for somebody to actually go through all of that code and look for certain aspects. And sometimes people can also, what I like to call, have blinders on when they're doing the review, in terms of they're seeing the same thing over and over and over and over again, and after a while they kind of miss out on something and they skip it completely, and then that bug then goes into your production and all hell breaks loose. So that's another problem with manual static code analysis as well. It's not ideal for agile and DevOps. As you know, agile and DevOps tend to be very quick. You have, I think it's sprints for agile, and well, DevOps, it's continuous, non-stop. And yes, the review cannot be done by one person for a manual review. As for automated, the biggest problem with automated is that you have too many false positives. And when we go through the tool today, you'll see what I mean by too many false positives. It's a lot of, you can have a lot of false positives, right? Scan times can be very extensive if you don't optimize them. And we kind of speak on optimization and what types of optimization you would want to do with your automated tool. And automated tools are also only as good as the rules used to detect the vulnerabilities. If the rules in your automated tool aren't good at detecting vulnerabilities, then you're probably, that automated tool is probably something that you may want to change out, or you may want to put in another type of review, probably a system where you have both manual and automated. I don't know. That's the problem with any type of automation. If the tool that you're using isn't that good, it's more or less the same thing as garbage in, garbage out. Right. So when we're looking at the software development lifecycle and security, I just put together a very quick table here showing the different software development life cycles and how it more or less relates to security. So we have like traditional agile DevOps. Methods are usually, for traditional, you have waterfall, Scrum. DevOps doesn't really have much of a method, so I just stuck in end-to-end because the whole idea of DevOps, at least from my opinion, is that it's heavily reliant on automated tools, and it's continuous, and it's integration with your operations as well to get whatever software or web application that you have into production. Right, so phases are more or less usually similar between the two. Requirements, design, development, testing, so on and so forth. Then when you look at the overall process, things tend to change, where traditional tends to be very fixed requirements, but when you look at agile and DevOps, requirements tend to change very frequently. right? And the development cycle is very fast. In terms of business impact, traditional tends to have longer release cycles, but whereas Agile tends to have smaller release cycles as well. But the main requirement is when you're looking at security. So with regards to the whole software development lifecycle and security, most of the time security should be defined in the requirements phase, or by extension, the plan phase. Right? Reason being is because you want to ensure that when you are planning out your application and the interactions your user will have with your application, and by extension, the business unit, you want to ensure that those applications, those actions are well protected, and that the risk of interacting with your software is more or less reduced by ensuring that for every action you have some sort of protection in place, right? And it's better to do it in the requirements phase as opposed to when you actually then develop your application and then you realize there are lots of security issues and then you have to go back again. So it's always a good idea to kind of look at security in the requirements phase or the planning phase for DevOps, right? But with regards to static code analysis, more or less, like I said, it's a preventative measure. So most of the time, static code analysis usually is performed during the development and testing phases, right? Except for DevOps. DevOps, because of the way how DevOps works, the whole idea be in ensuring that automation, there's some level of automation going on. The tool can actually be part of your continuous integration, or the whole idea. Sorry, let me think about this part, exactly how I want to say it. The software tool can actually be a part of your workflow, right? And because of that, it actually kind of improves the whole DevOps, workflow, and it kind of also helps you get more stable software into your production servers, as opposed to, well, I guess the other two methodologies here, where more or less static code analysis is done during development. Right? So this is more or less how security is kind of defined in the whole software development lifecycle. I did this just to kind of give everybody an overview as to where static code analysis kind of fits in, and where you should probably define security or your security requirements as well. So moving on, we have here the automated static code analysis tools. So I have here from C++ to PHP, JavaScript, Python, Java, .NET, Ruby, Ruby on Rails, and multiple. Now, I couldn't list all the languages on this slide, so I kind of did the ones that are more or less popular, or the ones I've seen in the Caribbean developers group. So when you're looking at automated static code analysis tools, you have open source and you have commercial, right? So as you can see here, I put down more or less the open source ones, at least the ones that I know of, and the commercial ones, at least some of the ones that I know of. If you will notice, there are a lot of open source ones for like, and especially for like the individual languages. So sometimes, even though if you're here for C++, you have 1, 2, 3, and 1, 2, 3. If you actually probably go on the internet and you look for all the open source static code analysis tools, you're going to get a whole heap of them, right? As opposed to the commercial ones, right? PHP, there are a couple, but RIPS and PHP MD are the two open source ones that I know of. In terms of commercial, there's no real individual or specific static code analysis tools for PHP. JavaScript, Node.js Scan is actually pretty good, and ESLint and JSHint are actually pretty good. For commercial, JSLint I know is pretty good for Node.js. And well, you have Python, PyLint, Java. Well, for Java, find bugs and find security bugs and OWASP dependency check are actually really, really good as well. For .NET, I know Roslyn Security Guard is actually really good. And Ruby, Brakeman. And then you come down to the multiple. Now, the multiple is basically multiple languages. So not only do they do C++, PHP, JavaScript, Python, Java, .NET, Ruby, they also do COBOL. I think Sonarqube does SAP, SQL, TypeScript, and all those different types of files, right? So today we'll be looking at Sonarqube, but you also have PMD, Yazaka, and Koala. Yeah, that one is a new one. Not too familiar with that one. Well, and for the commercial side, there are a lot of the commercial side. I know at KPMG, well, not KPMG Trinidad, but KPMG International, when we're looking at static code analysis tools, we tend to use Checkmarx and Veracode. IBM AppScan, I'm not too sure about, but I've heard one or two good things about them. So these are just more or less the various tools that you would see out on the market. There are a lot of open source ones. Of course, if you know how open source software is, you either pay for the support to kind of understand how to do these things, or you pay with time in order to understand how they work. Right? It's more or less up to you, as opposed to commercial, which more or less the commercial side, you would you get both support as well as the application. Anyway, so we're now going to kind of move on to the demo here. So for this particular demo, we'll be doing a static code analysis of the OWASP vulnerable application named Juice Shop. This is actually a Node.js type application. It was recently released, I think, if I remember correctly, sometime either early this year or late last year, to give OWASP enthusiasts and as well as security enthusiasts a vulnerable application, a vulnerable Node.js application to practice on. So we'll take a look at that. In terms of the automated tool we'll be using today, it will be Sonarqube. We're looking at the 6.74 LTS version as long-term service versions. Usually when you're dealing with open source software, my suggestion, always take the long-term service editions. Those are better as opposed to the versions that they release subsequent to LTS. And I installed it on a Windows 10 laptop. The backend would be a MySQL 5.3 database, and we'll be using the Oracle JDK 8. So let me come out of this. So in order to, right, so you could get Sonarqube from this website, this web address, sonarqube.com. As you could see here, They more or less state how many languages there are. As you can see, you have Java, JavaScript, C++, C Sharp, COBOL. Let's see what else they have. SQL, Python, TSQL, VB6, Flex, Go, Objective-C, so on and so forth. All right. In terms of the OWASP Juice Shop, you could kind of get it here at this particular website. Yeah, sorry about that. You can get it at this web address. Kind of goes into the description of what it is. It's a Node.js Express AngularJS application for people to practice on. You could get the architectural overview as well as an introduction video. And there's a book as well, companion guide. Cool. So let me see if the server is up. Right, server is up. Right. So let me just show you guys the Juice Shop application before I start the scan. Yeah, this will take a little while. Here we go. So we're listening on port 3000. So this is our Juice Shop. As you can see, a lot of stuff, a lot of products that you could view. More or less a very working web application. Contact us, so on and so forth. All right, good. So that's it. So let me come out of that. Yes. All right, okay. So one of the things about Sonarqube is that, so let me just go into Sonarqube here. So Sonarqube kind of comes in two parts. You have the server edition, well, more or less the server. The server could be, you can actually put it on your development machine, or you can install it on your development machine, or you can install it on a server that you have access to, and you can, a remote server, and you can actually scan your application on your development machine and send all those results to the remote server. So for this particular demo, I installed it on this machine locally, this being my development machine. All right, so this is what Sonarqube looks like. As you can see, there are a lot of integrations as well. It integrates actually with Visual Studio, Maven, Gradle, Jenkins, and Apache Ant. Right? So, like I said, there's the server, and then there's the scanner. The scanner is something that you have to download separate to the server. You can actually find it in the documentation under analyzing code. Under analyzing code, you could see it right here, running the analysis. If you want to do it for .NET projects, you have the MS Build. If you're doing it for Maven minimal configuration, you have this. Gradle is this. Ant is this. Jenkins, if you're using Jenkins, you have that. But for today, we'll be using the Sonarqube scanner. So you just choose the one for your particular distribution. I'm using Windows 64-bit, so I downloaded this earlier. It also shows you what you have to do in order to set it up. So you kind of take that into consideration as well. One of the things that you should do as well is ensure that the Sonar scanner, if you are using the scanner, you have to ensure that it's installed into your directory path. This is so that you can actually run it from anywhere in your machine. So let's see if I can pull it up here quickly. Here we go. On Windows, that would be your environment variables. So I have it installed right here. So, well, I think first I actually set up a variable called obpath, which is more or less this folder on my C drive. And then I kind of inserted it into my actual path here. So this is where I install the scanner, and this is where the scanner's executable is in the bin folder. So you have to ensure that it's added to your Windows path or your Linux path. However you want to do it, I leave that up to you. Another thing that you have to take into consideration as well is that you have to create a configuration file in your root directory called Sonar Project Properties, right? This configuration file is what, when you run your scanner, this is the configuration file that would be used by your scanner to actually scan the contents or the files within that particular folder, right? Or the particular web application that you'll be using, all right? So I already have a Sonar. Right, so I already put one here in this is the Juice Shop application folder. So I already have one here, right? So just for ease, excuse for 1 second. Where is it? Where did I put it? Right, there we go. All right. So this is the Sonar project properties. So I'll just copy this across. Right. So a couple of things that you have to note with the project properties. You have to have a project key. So the project key must be unique to that particular application, because that's what Sonarqube actually uses to identify that particular application, right? So seeing as this is Juice Shop, we will name our project key OWASP Juice Shop, right? We'll give our project a name. So this is OWASP Juice Shop. The version, I think the version was what? 7.3.0. 7.3.0. Right, and we'll save that, right? So this is what the project key is what will be used to uniquely identify our application in Sonarqube. We'll of course, give it a project name. We'll have a project version, of course, for good practices, right? So project sources. Project sources is what is more or less where your source code would lie, or more or less where it would be located, right? So for here, we just put a dot because we already are in the root folder that we're going to scan. If your source code was in, let's say, a particular subdirectory, so let me see here what we have here. So let's say your source code was in the app subdirectory. We would remove this and type in app, right? But seeing as all our code is all here within this directory, for now, we'll just leave it as that. So now that you have your Sonar project properties done up, right, we can now run the scanner. So to run the scanner, it would be sonar scanner.bat. So right now, this sensor is actually going through and finding all the different files that we have. So as you can see, in this application, we actually have CS files, JS, PY, TS, and XML. So in other words, we have XML files. TS, I think, is TypeScript. PY is Python. We have JS files, and CS would be C# files. So there are also a couple of errors here I'm noticing. Some of the XML files I can't seem to parse, so we'll leave that for now. So because we're scanning the entire web application, it's going to take a while. And as you can see, we have multiple languages within this. So even though it's a JavaScript application, because of the way how this particular developer made it, you could see that how there are a lot of there may be a lot of unnecessary files.
Okay, so while we're waiting, if anybody have questions, feel free to ask so we can answer them. So I would have a question for someone who is now learning about this. Which would be the best route to start actually learning about the Square Cube?
Sonarqube? Okay.
Yeah.
So like I said before, Sonarqube is an open source static code analysis tool. So most open source software, you have to actually spend a lot of time trying to figure out stuff and reading the documentation. In terms of actual tutorials or easy to use tutorials, I'll be honest with you, I have not found any as yet. I've seen a couple here or there, like one-page tutorials. But most of my experience with this software is through try and fail, more or less practicing as much as I can to try and understand the different features.
Okay.
So yeah, that's unfortunate. That's the difficulty with this. Because you see what happened is with Sonarqube, they also have a paid commercial version. And that paid commercial version is, unfortunately, comes with the support. So, I mean, if you don't want to go through the hassle of trying to figure it out yourself, you could always try and pay for the commercial version and get the support that is necessary to learn a little bit more about it.
Okay, and also you could do some tutorials through your trials and errors.
Yeah. So I'm going to now make the biggest mistake and just type in admin to log in. Please don't ever use that username or password. Okay, and as you can see, our application has finished, right? And as you can see as well, we have a lot of bugs, a lot of vulnerabilities, a lot of code smells, coverage, and duplications, right? So just to go over, bugs are more or less related to actually might be better to show you. Right. Right. So these are the more or less the various bugs that they would have found. So stuff like there was a type error, geometry might be defined, might be null or undefined here, or structure or edit of this code blocks not the same, missing return statements, stuff like that. Little things that can cause issues more or less in your code or can be exploited. That's what I consider a bug, right? So you also have vulnerabilities as well. These are actual security vulnerabilities. Here we have one particular vulnerability here being review of the arguments of the eval call to make are not validated. And this is related to, just go back here, right? So that's related to this particular expression here, right? And it's actually a cross-site scripting vulnerability as according to OWASP, right? But we kind of get into this a little bit later on. For now, just go back to the overview screen, right? So when you look at the application, this is everything more or less related to the application, right? Oh yeah, code smells are, how I would describe code smells, boy. Code smells looks at like duplicate code, variables that aren't used or were randomly declared, expressions that aren't evaluated. Some of it, also you have to remember some of these things are false positives in between. Everything that you're seeing here, they may have false positives, right? I'll try and see if I could find a false positive. I found one last night. I can't remember where it is, but we'll get into that. Right. Now, another thing you kind of have to realize, according to the scan, we have that's 23,240 JavaScript lines of code. We have 19,000 Python and XML. Now it's kind of weird that we have Python and XML as well as JavaScript in a actual JavaScript type application, right? And as you notice, well, the scanner took a very long, and now we have all these bugs and all these code smells. I mean, this is this is 1.6. This is what? This should be 1,600 issues that we have to sort through. And not all of these may be related to the JavaScript. This might be related to the Python. Also, if you know and understand JavaScript applications, a lot of them are packaged with dependencies. And you may not want to scan those dependencies, right? Because those dependencies themselves may have errors, and that is what is actually adding to these amounts, right? It could be adding to your bugs, and it could be adding to your code smells as well, right? So this is where it comes to kind of the point where I was talking about, you know, straightening out or more or less optimizing your scans now to kind of reduce and make sure that you actually focus on the code that you develop as opposed to the code that is packaged with your application. Right? So let's kind of go back to the thing here, right? So if we are looking at the tree here, most of our application code sits, if I remember correctly, would be an app. Some would be in, well, we wouldn't be using config, we wouldn't be using data encryption keys, lib, we may be scanning lib. We'll be definitely scanning models. Node modules would be all your dependencies. So for this particular application, we have a lot of dependencies, and all these dependencies would have been scanned and may be adding to your bugs and to your code smells. So you would want to exclude all your dependencies from the scanning as well. And we'll get to that just now, as well as roots. Yes.
Okay, not to cut you off, but as for time, it's almost time. So.
Ooh, okay, all right. All right.
But in the chat, no one has asked any. Oh, we have one question. Not sure if this was explained already, but are you able to write your own rules for determining problems? So
yes, yes, you are actually able to write your own rules. There's also, right, under the administration tab in Marketplace, there are actually also additional, I guess, plugins that you can use as well. You have actually a whole list of plugins. So you have stuff for like GitHub, GitLab, Groovy, and so on and so forth. But yes, you can also run your own custom rules as well. But that is a little bit advanced, and I haven't actually reached that far. Most of the times I just use the plugins, and what I do is that I then optimize my scanning. So I ensure that I will probably scan once, and then I would actually start eliminating directories and particular paths and try and ensure that the code that I actually programmed myself is actually what is being scanned.
Okay. Yes. Our time is running short, so.
Okay, well, I'll just go to the last slide here. Just some quick takeaways here. I would have liked to kind of go through the optimization with you guys, but seeing as time running out, we'll just kind of wrap up here, right? So basically, to improve your quality of code and reduce the software bugs and vulnerabilities and logic flaws, you have to try and take a proactive approach. And doing static code analysis is one of the ways of doing that. As we kind of went through, we kind of talked about manual and automated, and they're there to kind of assist developers with ensuring that, they can identify the flaws in the code, but it's very important that you take corrective actions when you see a flaw, right? Don't ignore it. It may eventually come to something terrible, right? And then, right, static code analysis is a good proactive measure, but always remember to look at dynamic testing, right? Dynamic testing meaning use of a tool like OWASP, ZAP proxy, a proxy type tool, or burp, to kind of test and actually use your application and see what issues may come about while using your application. What do you call that? I think is an interception proxy. But that could be done we could probably speak about that another time if anybody has questions. And last but not least, ensure that security is integrated throughout your entire software development life cycle, especially at the start of it. Don't leave it as an afterthought. Questions?
Okay. Any questions, guys? No questions coming in at the moment. you have 1, 2, 3. You have 4 minutes. So if you want, if we can go through the last part that you said you wanted to
Oh yes,
show.
the optimization.
Yeah, optimization. We could utilize. If we go over a minute or two, that is okay. So
Okay, so let me do the optimization quick. It's probably a good thing that I kept this last night. Right, so for the optimization here, right, there's some quick things. There's something here, there's another property that I added here, which is exclusions, which will take out the dependencies. It will take out the Python files and the XML files. All right. Also, I ensure that it only looks at JavaScript files. Right. So we save that. Rerun the scanner. And so as you can see, it's excluding these sources now. So now this should be going at a level pace now.
okay, so while you wait, so if anybody needs to get in contact with you, could you just give us some contact information? Okay, we seem to have lost our presenter. So in this, we can hold on at least 2 minutes or a minute to see if he comes back on. I'm not too sure, technical difficulties. Okay, so it seems like he had a bit of technical difficulties and has left the chat. But we would be back on again tomorrow morning from 12 to 1 for It's Funky with Azure. Just let me just double check to give you all the correct upcoming event tomorrow. So check us out tomorrow for Funky Development with Azure. It's at 1. So thank you guys. Thank you all for listening, and we'll be back again tomorrow. Have a good evening. Bye.